Welcome back to the Deep Dive, where we cut through the noise of corporate technology and deliver the strategic insights you need to stay ahead.
Glad to be here.
Today, we are taking on, well, probably the most ambitious project facing any major corporation right now. We're talking about blueprinting the zettabyte enterprise.
It definitely sounds intimidating,
Yeah.
and to be fair, it is.
Right.
But our mission today is to unpack a comprehensive template, a kind of North Star architecture, if you will.
North Star, I like that.
It's what organizations really have to adopt if they want to move beyond just, managing data chaos. We're talking about modern cloud architecture, big data management, and fundamentally integrating AI into the very DNA of the business.
And the stakes here couldn't be higher. I mean, we are operating in what people call the zettabyte era. Data volumes are growing at a rate that's frankly hard to comprehend. We have to reckon with this massive shift to the cloud, and crucially, the market is demanding decision-making at real-time speeds. So our goal here is to analyze how organizations can make that transition, how they can move from a reactive IT posture, always trying to fix yesterday's problem, to becoming a strategic transformation engine.
Exactly. And the core structural challenge is that this exponential data growth, it's often a bit of a mirage.
A mirage? How so?
Well, if the underlying architecture isn't holistic and, seamlessly integrated, that petabyte of data you've collected just becomes a petabyte of liability.
It's not an asset.
It's not an asset at all. It remains locked in these isolated systems, these frustrating silos, which actively damage profitability and stifle any real growth. We need a system where every single data point is instantly accessible and, more importantly, actionable.
Okay, let's unpack that immediately. I want to focus on the strategic tension here. Overhauling an entire technology landscape it's massively expensive, it's disruptive, and it's risky. This can't just be about being modern.
Well,
What are the concrete, high-level business values that actually justify this kind of undertaking?
it has to be an existential investment. It can't be an IT project. It must be tied directly to strategic business outcomes. Our sources highlight that the drivers aren't technical at all. They are purely business.
Okay.
The first major driver is the need to drive innovation and activate entirely new business models.
Right.
If your core IT systems are rigid or slow or just tangled up in legacy code, you simply cannot experiment.
You're stuck.
You're stuck. You can't launch a new service line in a matter of weeks. It takes months, sometimes years. And by then, the opportunity's gone.
That speed to market is really the defining characteristic of innovation today. If you can't iterate quickly based on, changing customer sentiment, you lose.
You lose, that's right. And the second driver, it sort of addresses the long-term view, creating a sustainable and scalable technology landscape.
Sustainable meaning what exactly?
We're talking about architectures that are flexible enough to handle today's petabytes and, more importantly, tomorrow's zettabytes, without requiring a complete, costly, and resource-draining restructure every few years.
So you're not building tomorrow's legacy system today.
That's the goal. It's about building technology that lasts without becoming a problem the minute you deploy it.
But let me introduce the tension here, because you say sustainable, but this blueprint requires massive cloud investment.
It does.
So how do companies ensure they get a faster return on investment, ROI, from this incredibly complex spending? I mean, that's the fifth driver on our list, and for most executives, it's probably number one.
It's absolutely critical, and it directly relates to the third driver, delivering delightful experiences.
Ah, okay. Connect those for me.
This is where the ROI justification really crystallizes. An integrated architecture doesn't just improve a customer's checkout speed by a few milliseconds.
Right.
It ensures your supply chain can promise accurate delivery times, and it ensures your field service team has the right data to solve the problem on the first visit.
So it's the whole chain.
The whole chain. If you deploy a fantastic new system that helps the sales team, but the data is immediately siloed from logistics, your ROI vanishes because the customer experience is still broken at the end of the day.
Yeah.
The real ROI comes from the synergy, not from the individual components.
So we're talking about delighted customers, suppliers, and importantly, employees.
Yes.
And that leads to the fourth driver you mentioned, unlocking the potential of the existing IT landscape. Because most big organizations have billions invested in existing ERPs and CRMs. This blueprint doesn't mandate burning it all down, does it?
Precisely. And that's a key point. It acknowledges the huge investment that's already been made. The goal is not to rip and replace everything.
Good to hear.
It is to make the existing assets smart and accessible. This new architecture acts like a massive nervous system that connects and governs the existing organs, enabling strategic transformation that meets genuine business needs, often just by surfacing data that was already there but was completely inaccessible before.
That takes us back to the competitive advantage. The sixth driver, and I think the final, often overlooked driver, talent.
The sixth driver is pretty straightforward, differentiating the company from the competition. If your rivals are operating on quarterly forecasts and manual data reconciliation,
Which many are. Yeah.
and your enterprise is real-time and predictive, you have an almost insurmountable advantage in speed, in agility, and in your cost structure.
And the talent piece.
On the seventh point, attracting high-quality technology talent, it's a critical, self-fulfilling prophecy.
How so?
Software developers, data scientists, architects, the best ones, they want to work on modern, coherent, flexible platforms. They want to use the cutting edge of AI and cloud technology.
They don't want to maintain a system from 1995.
They absolutely do not want to spend 60% of their time wrestling with disconnected, ancient legacy systems and performing manual data cleaning. So a modern, clean, well-governed architecture is a powerful magnet for the best talent, which in turn accelerates your transformation even further.
Okay, here's where the magic seems to happen, and it feels like the most strategic point of this whole section. The blueprint emphasizes harnessing the powerful synergy of operational data and experience data. We often hear this called the merger of X data and O data.
The merger of X data, the experience data, and O data, the operational data, is the core engine of this entire blueprint. It is no longer sufficient to know what happened, an operational fact like a machine breaking down or a customer abandoning a shopping cart.
That's the O data.
That's the O data. You must immediately connect that to why it happened and, crucially, how the customer felt about it. That's the experience fact, the X data.
Can you give us a quick, punchy example of that synergy in action?
Sure. Think about supply chain. Operationally, the O data, you know a shipment was late.
Right, standard stuff.
Traditionally, you might just absorb the cost, maybe apologize, and move on. But when you blend in the experience data, the X data, a customer support transcript showing frustration, a low net promoter score from a follow-up survey, and maybe some negative social media sentiment.
Okay, I see where this is going.
You suddenly realize the late shipment didn't just cost you the freight charges. It cost you a long-term customer relationship. By blending those emotional insights with the operational facts, you can shift from simply fixing the broken process to preventing the future loss of customer lifetime value. And that blending, that's what opens entirely new dimensions of growth potential. So once that high-level business imperative is accepted and everyone's on board, we have to translate it into a core, actionable data strategy.
Okay.
And this is vital. Data strategy is not a standalone IT function anymore. It can't be. It must be mandated and driven by clear business outcomes.
From the C-suite down.
From the top down.
Yeah.
This leads us to this critical framework of three blending themes, what we can call the three pillars of the modern enterprise data strategy.
Walk us through those pillars and then maybe show us how they interact, because I'm guessing they don't exist separately.
No, they're completely interwoven. Pillar one is the foundation, business value drivers. This forces leadership to define right up front how exactly data will be leveraged to fulfill the business plan. It's about designing the business strategy with data as the competitive weapon.
So the goal isn't just becoming data-driven, which is a phrase we hear all the time.
It's too vague.
Yeah.
The goal is to achieve specific, often dual outcomes. For instance, simultaneously increasing customer lifetime value and operational efficiency. One can't sacrifice the others.
Right. If you cut costs, your operational efficiency by getting rid of customer service staff, you absolutely destroy customer value.
You do.
And if you spend infinitely on customer service to delight them, you destroy your margins. So the architecture has to enable both to thrive at the same time.
Exactly. That brings us to pillar two, big data management. Now, this is where most legacy organizations fail, because their data systems have grown reactively over time.
Organically, they might say.
Organically, which is a nice word for chaotically. You have data ingestion tools, data replication processes, data cataloging systems, distributed processing engines, but they were all chosen ad hoc by different departments over the last decade. And the result is a fractured, inconsistent landscape.
The classic sprawl. You end up with, 15 different ways to ingest a file and 3 different versions of the truth, all running on different incompatible platforms.
That's the perfect description, and it's the antithesis of this blueprint. In the zettabyte era, we have to move past that sprawl. We need to build a coherent, scalable data intelligence strategy that shapes a unified big data management platform. And this platform isn't just about storage, It's the brain that processes raw events into actionable insights.
So what are some specific required transformations that this pillar has to support? Give us some concrete examples of capabilities that a modern big data management strategy must enable.
Okay, a few things. We need transformation capabilities that can take raw IoT event streams.
Huh.
I'm talking a machine sending 100 data points per second, and transform that noise into clean, enterprise-ready data that can trigger an actionable process
So separating the signal from the noise.
instantly, often using intelligent robotic process automation. We also need to build connected data warehousing. We want analytical power that is consumed at the exact moment of experience.
What does that mean in practice?
It means connecting a multifaceted data warehouse across diverse distributed data assets with live application connections. So an analyst's predictive model runs directly against the live order management system, not a data set from last week.
In Pillar 3, the critical link, business process integration. This is the strategy that ensures the data doesn't just sit there looking beautifully managed. It forces it into every corner of the business.
This is so crucial because siloed thinking is often enabled by powerful technology. A supply chain team might go out and buy the best new planning tool on the market, optimizing their specific metric.
And they hit their numbers.
They hit their numbers, but they completely ignore the impact on marketing's data structure or finance's reporting needs. Operating in that kind of isolation sacrifices massive exponential gain. The true win isn't just making the supply chain efficient, it's making the supply chain efficient in lockstep with the sales forecast, financial reporting, and customer experience feedback.
So integration becomes a strategic concept, not just a technical task. It's the business-driven synergy required to achieve that exponential gain you mentioned.
It has to be.
Let's look at those real-world examples of data-driving transformation that illustrate this synergy, because this is where the theory becomes real. Let's start with an internal transformation, employee experience.
Right. The modern workforce is dynamic, and talent retention is a huge cost driver for companies. The blueprint suggests that data can dramatically improve employee engagement. Imagine providing personalized learning recommendations. But these aren't based on some generic one-size-fits-all schedule. They're based on a unique blend of 3 key data streams.
And what are those streams?
First, the employee's existing talent profile, their skills, their project history, their current role. Second, the company's strategic goals. Where does the business need talent in the next 18 months? What skills are we missing? And third, and this is the new part, their emotional workplace experience data.
Emotional data.
Survey feedback, productivity data, even sentiment analysis derived from internal communications. That blend talent, strategy, and emotion allows the company to offer highly personalized, highly relevant career development paths. It can turn a potential flight risk into a deeply engaged, long-term asset.
That's a huge leap from the old world of mandatory compliance training. It's using data to personalize the future of the employee, not just manage the present.
Exactly.
Okay, now let's pivot to a classic industry problem. Supply chain efficiency and the dreaded bullwhip effect.
The bullwhip effect. It's a killer for profit margins. For those who don't know, it's where small changes in consumer demand at the retail level lead to these massive inefficient swings in inventory and ordering further up the supply chain.
Right. A customer buys one extra tube of toothpaste, and suddenly a factory 1,000 miles away orders a whole new tanker of chemicals.
That's a great way to put it. The architecture solves this by providing real-time, predictive visibility across the entire demand and supply network.
How does the architecture physically achieve that real-time predictive visibility? What's happening under the hood?
It requires that robust big data management platform we talked about in Pillar 2. It ingests thousands of market signals, social data, macroeconomic indicators, weather forecasts, and then blends that with transactional data from the ERP system, like sales orders, inventory levels, and production schedules.
And then the AI comes in.
Then the data science platform runs continuous optimization models against this unified real-time view. The result is predictive insights that allow the company to anticipate demand fluctuations before they materialize. That leads to increased inventory turns, lower warehousing costs, and much less obsolete stock.
And the final example covers the complete customer journey, which I'm guessing must also tie back to that internal efficiency.
Absolutely. We are talking about leveraging big data to drive the entire order management lifecycle. This starts way back at interest generation, where marketing uses personalized data insights to target the right people. It moves through purchase behavior and, crucially, accurate inventory checks, the available to promise we mentioned. Then it flows seamlessly into the physical order processing, logistics, service fulfillment, and finally, the financial settlement.
The key being that single thread of data.
Yes. The key is that the data insights, often generated by AI, must inform every single step, preventing data decay or latency between stages. The integration layer has to be seamless enough to support a single continuous intelligent journey for every single order. And to support that continuous intelligent journey, we have to turn to the engine that connects everything, the integration layer.
Right.
You mentioned the tension earlier. This layer has to deal with the messy reality of the enterprise data ecosystem, which is, to put it mildly, extremely heterogeneous.
And intimidatingly diverse. I mean, the challenge isn't just connecting to modern cloud apps. It's connecting the 1980s mainframe system running payroll with a live IoT sensor in a machine 3,000 miles away. You need a kind of universal translator.
That's a perfect way to put it. Let's quickly group the types of sources this layer has to ingest and integrate. On one hand, you have let's call them structured and traditional sources.
Old guard.
The old guard. Your standard RDBMS, relational databases, and the high-speed fast access systems like in-memory databases. These run the core transactions, the OLTP systems.
These are the systems that if they went down for 5 minutes, the entire business would just stop.
Exactly. And then you have the older yet still critical long-term analytical stores, the OLA systems and the traditional data warehouse components. And we can't forget the long tail. Flat files like Excel and CSVs and the venerable legacy applications that handle mission-critical processes nobody wants to touch.
Then on the other hand, you have the new and unstructured sources, which are really being driven by the cloud revolution.
Right. These include the hyperscale enterprise cloud storages, big data infrastructure like Hadoop HDFS, and modern flexible NoSQL databases. Most critically, we have high-velocity sources, streaming data from IoT devices and mobile or machine data, plus external inputs like social media and graph databases, which are great for mapping complex relationships. The integration layer has to be agile enough to handle all of them without breaking a sweat.
This brings us to the core mechanism for handling this monumental task: the Integration Platform as a Service, or IPAS. And we need to view the IPAS not as a single tool, but as a critical strategic tool set composed of 7 key components. These are what's necessary to mitigate risk and accelerate value.
Let's start with the absolute non-negotiable foundation, security. Component 1 is identity and access management, consent, and security. If you're connecting data from a customer's phone to an ERP system, you must ensure trust.
What's the strategic value here beyond just standard security protocols?
The value is enabling frictionless interaction while maintaining strict compliance. The platform has to provide a robust system for registration and self-service for every user, customer, supplier, employee.
Right.
But at the same time, it must strictly comply with evolving legal and IT regulations concerning data consent and privacy. The integration layer handles this complexity centrally, so the individual application developers don't have to rebuild compliance for every single new app they create.
Component 2, the universal connective tissue, API design and management.
APIs are the currency of the digital enterprise. It's that simple. You're managing thousands of integrations across B2B portals, CRM, ERP, mobile apps. You need a centralized hub to manage every single API, old, new, internal, external, ensuring consistent governance, security, and version control at scale.
Because without that central management, you get what people call shadow APIs.
Exactly. Shadow APIs that pose massive security and maintenance risks down the line. It's a huge problem.
Okay, component 3 addresses the complexity of external business relationships, B2B and EDI management.
For any large global enterprise, trade requires complex, highly structured electronic documents. The IPAS has to be able to support all the major B2B EDI formats, whether it's X12, Edifact, RosetteNet, and handle the necessary transport protocols like AS2, FTPS, and HTTPS.
And the strategic value here is speed.
It's speed in partner onboarding and directory maintenance. You can't afford to spend weeks on manual setup every time you bring on a new major logistics partner or a raw material supplier. The IPAS automates and monitors this crucial exchange.
That brings us to component 4, which is all about acceleration and stopping that terrible habit of rebuilding the wheel every single time. The integration catalog and prepackaged templates.
This is your insurance policy against developer burnout and slow time to value. To accelerate deployment, you have to leverage prepackaged content, out-of-the-box integrations, and best practice accelerators.
Give me an example.
Let's take the available to promise process we mentioned. Calculating if you can fulfill a large multi-item customer order in real time is incredibly complex. It requires checks against inventory, production schedules, logistics capacity.
So if a team had to write the 20-step logic for that from scratch every time?
It would take months,
Yeah.
and it would be different every time. But if the IPAACE provides a pre-built, tested, available to promise business package, an accelerator that simply needs to be configured and connected to your specific ERP and data warehouse, you cut deployment time from months to weeks.
And the integration catalog is where these live.
It's the library. It houses these valuable certified assets, allowing the company to continually reuse and maintain them efficiently.
Moving to the control center, component 5, data orchestration, monitoring, and governance. As volume and velocity increase, control becomes absolutely paramount.
Consider the strategic item of omnichannel data visibility, particularly for something like pricing. Pricing data comes from finance, it gets adjusted by sales, it has regional variations stored in multiple systems.
It's a total mess.
It needs to be collated, harmonized, and used across every single channel, the e-commerce site, the mobile app, the B2B portal. If a small change is made in the ERP pricing database, you need real-time orchestration to ensure that update is reflected everywhere, instantly and accurately. The governance capabilities in the IPAS provide the necessary framework to scale this securely.
Component 6 directly addresses the big data processing needs: data pipeline, ingestion, processing, and enrichment. How does the IPAS handle those raw, continuous data streams?
It must be robust enough to support petabyte volumes and live streaming. And critically, it enables complex data enrichment on the fly. Let's go back to our predictive maintenance scenario.
Okay.
If a field engineer logs into a mobile app to check a machine, the IPAS must instantaneously pull the service contract data from the CRM, the maintenance history from the asset management system, and the live IoT insights from the streaming platform, all in milliseconds.
And it stitches them all together.
It enriches the engineer's view with predictive failure alerts generated by the AI engine. The IPAS is the traffic cop that merges and enriches these disparate streams immediately.
And the final component addresses the long-term, painful reality of maintenance: data quality and cloud automation.
With hybrid systems, some on-premise, some in the cloud, and hundreds of applications involved, maintenance cycles become an absolute nightmare. The IPA has to protect and manage integration data quality at scale, automatically identifying data drift or corruption,
And automate the fixes?
and automate the maintenance of the environment itself. It requires advanced cloud automation and DevOps best practices to manage the environment without continuous, costly, and manual intervention from IT staff. It's about automating the maintenance of the complex connections themselves. All right, so now that we have the robust pipeline, the IPAS in place, we have to shift focus to the quality of the raw material flowing through it.
Right.
If integration is the pipes, then this section is all about the quality of the oil. We begin with the core data engine, the master data platform.
Master data. It sounds so dry, but in my experience, bad master data is often the single biggest killer of major IT projects.
It is the bedrock, and you are absolutely right. The pain point in large enterprises is fragmentation. A cost center, an employee ID, or a customer record might exist independently, and often with slight variations in the HR system, the payroll system, the ERP, the CRM, the logistics software, you name it.
And when finance runs a report, they spend 3 weeks just trying to reconcile 5 different versions of a customer's name or a cost center number.
Exactly. The report is useless until they do. That is why the centralized master data hub is so essential.
So what does the hub actually do?
The hub's function is to ingest all these disparate data sources, map them correctly, validate the inputs, and then orchestrate the distribution of the golden record, the single certified version of that data, consistently across all relevant systems in the landscape. It is the definitive central authority for those core business entities.
And if the hub defines what the truth is, I assume master data governance, MDG, provides the rules and the structure to keep it that way.
Yes. Data quality deteriorates rapidly. It's just entropy. It's due to human error, system updates, changing business requirements. Governance provides the necessary framework to combat this. It aligns data stewardship with the broader business strategy and organizes data ownership.
And that's crucial.
It's crucial. Someone must be accountable for customer data, and someone else must be accountable for product data. It sounds simple, but many companies don't have that clearly defined.
How does that framework actually create a strategic advantage in the real world?
Governance ensures that specific, essential business rules are automatically invoked throughout the entire data lifecycle, from the moment a new product is created in engineering to the moment it's sold and invoiced. It prevents bad data from ever entering the system or propagating through the landscape. This allows the company to be truly data-driven, replacing that reliance on manual reconciliation and, tribal knowledge with certified, trusted information.
With the data quality now assured, we can finally pivot to the intelligence layer, the data science platform and its components. Component 1 is the powerful engine itself, the machine learning and AI coding platform.
This is the workshop. This is where the models are built and refined. It has to be flexible, supporting modern languages like R and Python, and it needs to provide access to vast, pre-packaged libraries, specifically designed for machine learning projects.
We don't need a list of every single specific algorithm here, but what is the range of capabilities this platform really needs to support?
Well, the platform needs to support the full spectrum. Everything from simple, quick-to-deploy models like regression models for forecasting, all the way through to complex ensemble learning methods for more nuanced predictive tasks. And of course, it must support massive computation-heavy neural networks and deep learning architectures for things like pattern recognition in unstructured data, like images or text.
And the key is that the platform scales.
The key is that the platform must scale compute resources on demand to run these varied models across huge data sets efficiently.
Okay, so component 2 translates that scientific output into operational reality. Robotic and business process automation, RPBPA.
This is the layer that ensures the predictive insight doesn't just sit in a dashboard somewhere. It has to trigger an action.
Right. Has to do something.
It has to do something. And to drive automation effectively, you need several components. Clearly defined business process workflows, user-friendly no-code platforms for rapid deployment by non-technical staff, and a library of pre-built automation components that can connect to various systems. And all of this has to be monitored by process intelligence to measure efficiency and governed strictly to prevent rogue automation from causing chaos.
And component 3, statistics, insights, and predictions, is where we close the loop, connecting the science back to the tangible business outcome. Let's return to the predictive maintenance use case, because it perfectly illustrates the full architectural loop.
It's the ideal litmus test for the entire blueprint. To predict a machine failure, the data you need is incredibly distributed. We need real-time telemetry from IoT sensors on the machine.
The edge computing data.
Correct. And that has to be combined with historical, financial, and asset data from the ERP, the cost of repair, replacement parts inventory. Then you need customer contract details from the service asset master, and location and technician availability from field service management and logistics.
The insight generated by the machine learning model is only half the battle. The real power is in the action it enables.
Exactly. The data science platform predicts a potential failure with, say, 95% certainty. The model then sends that alert to the automation layer.
And the automation takes over.
The automation layer, supported by the IPS, takes that insight and triggers a complex action sequence. It checks the ERP for parts inventory. It flags the closest available technician in the logistics system. It sends an automated alert to the customer proactively, and it initiates a field service order in the system, all before the machine actually breaks. The insight is completely useless without the robust, integrated architecture required to trigger the resulting action across those 5 or 6 distinct systems. The ability to execute that complex action sequence hinges entirely on agility, which brings us to cloud extensibility. The foundational strategy here is crucial, and it's a shift in thinking for many. You must extend applications outside the core of the main business systems. Okay, explain that. Why is keeping the core clean so important? Why not just customize the ERP system like we used to do for decades? Customizing the core application, that traditional approach, is the definition of rigidity. Every time the core application, your ERP, receives a necessary security patch or feature upgrade, all that customized proprietary code has to be tested, validated, and often rewritten. It makes upgrades painful, slow, and incredibly expensive. It locks the company into outdated versions of their most critical software.
So by performing extensions outside the core, using a dedicated extensibility platform, you keep the core clean, you simplify those upgrades, and most importantly, you enable rapid, continuous innovation in the extension layer.
That's it, exactly.
So we're essentially building separate, specialized services that just talk to the core system when they need to. What are the key architectural components of this dedicated extensibility platform?
Component 1 is microservices. This is the fundamental shift from monolithic applications. Instead of building one giant complex application, you decompose it into smaller, independent, interconnected services. Think of building a city with standardized interlocking Lego blocks versus trying to carve a massive monolithic statue out of marble.
I like that analogy. So what are the practical benefits of using those Lego blocks?
First, managing complexity. Each small service is far easier to maintain and update. Second, speed. The development teams can choose the best technology for each specific service. Java for one, Python for another, avoiding technological lock-in and speeding up the coding process.
And the third benefit.
Third, and this is perhaps the most valuable, is independent scaling and deployment. If your inventory check service suddenly gets hammered with 1,000 requests per second during a flash sale, you can scale only that microservice, leaving the rest of the application stable and unaffected. This supports rapid innovation through continuous deployment.
Component 2 addresses how those extensions interact with the data and logic modeling.
This is a key architectural decision point. When we build new logic in an extension, do we virtually access the existing data in the core ERP system? For instance, just reading the price of a product in real time. Or do we need data persistence? Meaning the data needs to be copied, synchronized, and maintained within the extension application itself. Making the wrong decision here can lead to massive data latency, or, conversely, overwhelming the core system with constant read requests. The platform has to support both virtual access and persistence seamlessly.
Component 3 is the lifeblood of complexity, intelligent workflows.
Workflows used to be simple, linear, sequential steps. Today's requirements are vastly more complex. Modern workflows have to span across multiple disparate applications.
Right.
They need to integrate machine learning intelligence, like the output of a sentiment analysis model, to make dynamic decisions. And they have to be multi-event driven.
Meaning they can be triggered by different things?
Yes, triggered by a customer click, a new entry in a database, or an IoT alert from a sensor. They have to handle diverse, real-time data sources and cross lines of business without any friction. This versatility makes them absolutely crucial for the cloud extension platform.
And component 4, the bridge to the business user. Low-code, no-code platforms.
Innovation cannot be bottlenecked by a small team of highly specialized, expensive developers. A strong, low-code platform is required to offer a business user-friendly experience. It allows people with deep domain knowledge but little programming background to quickly create applications or complex extensions, often through visual modeling.
But there's a big caveat here, right?
A huge one. A good low-code platform must also be enterprise-ready. It has to be scalable, secure, and offer pre-built accelerators that connect to your core microservices and data hubs. It can't just be a simple tool for building a departmental app. It must be a governed, enterprise-grade development environment.
Let's pull all of this together with a detailed narrative. The Field Technician App Case Study. This is an extension designed to solve a single, complex field problem, but it requires orchestration across the entire enterprise.
Okay. Imagine the technician is standing in front of a broken industrial machine. They open their custom-built mobile app, which was created on the low-code platform. That app is powered by the Cloud Extensibility platform, which is acting as the invisible orchestrator, pulling together all the disparate data needed for that service call.
What are the core inputs the orchestrator needs to gather first, just to get started?
3 critical inputs, and they are likely residing in 3 separate systems. First, the customer contract data from the CRM system. What are we legally obligated to do for this customer? What's their service level?
Okay.
Second, the precise pricing and inventory data from the ERP. What do the necessary parts cost, and are they in stock at the nearest depot? And third, the highly technical machine repair instructions from the engineering or asset management system, the step-by-step guide that is specific to that machine's serial number.
That's a huge blend of finance, legal, and engineering data just to start the job. So what happens once the platform has synthesized all that data?
The orchestration begins. The platform doesn't just display the information. It triggers a complex workflow. It generates the tailored mobile application view for the technician, providing real-time instructions and the ability to order parts with a single tap.
What if something unexpected happens?
Good question. If the repair requires an expensive deviation from the contract, say a part is needed that isn't covered, it initiates a real-time, multi-step approval workflow involving the field manager and potentially the customer account manager right there on their phones.
And the outputs have to span the entire enterprise too, not just the field service team.
Absolutely. Once the job is approved and completed, the workflow ensures 3 critical downstream actions occur seamlessly and automatically. The platform facilitates automated email communication of the work order and the preliminary bill to the customer. It updates the invoice record in the ERP for financial processing.
And the final piece?
Finally, it transfers crucial metrics about the technician's efficiency time on site first-time fix rate, and feeds that directly into the HR and talent system for performance review and personalized training recommendations. It's a single business transaction that spans 6 departments, entirely mediated and governed by the extensibility layer.
That is the definition of integrated intelligence. Now, let's pivot to the data science and production planning optimization case study to see how the architecture scales a basic mathematical model into a massive, profitable enterprise capability.
Optimization modeling is foundational to efficiency. Most people learn this via a very simplified classical model. You have a single plant, you're forecasting demand over 4 quarters, and you're using levers like regular production, overtime, and subcontracting, each with varying costs.
Right.
The objective is purely to minimize total production cost under some basic inventory and capacity constraints.
The numbers are clean, the model is straightforward. It's something you could solve in a high school math class or with simple software. Let's assume the basic data. Demand forecasts fluctuate from 800 to 2,500 units, regular capacity is stable at 1,000 units, and variable costs range from, say, $25 for regular time up to $31 for subcontracting. A good optimization model might calculate a minimum total cost of, let's say, $196,800.
That's the textbook answer. But in the real world, that model is essentially useless in isolation.
Why?
Because it ignores complexity, volume, and velocity. The need for this massive enterprise architecture blueprint stems directly from the 4 real-life scaling challenges that completely kill that simple model.
What's the first scaling challenge?
Modeling across multiple distributed plants. The simple model assumes one factory, one location. An enterprise needs to optimize production across dozens of plants globally, factoring in varying labor costs, local tax incentives, different raw material suppliers, and distinct transportation costs for each location. This multiplies the complexity by a factor of hundreds.
And that requires real-time data connectivity, which I'm guessing is challenge number 2.
It is.
Yeah.
The system cannot be disconnected. The minute that simple model is solved, the input data like the cost of overtime or the current inventory level is already outdated. The model must connect in real time to your various inventory, human resource, and manufacturing systems across all your plants simultaneously. If a machine breaks down or a labor strike occurs, the optimization model must immediately rerun the calculation and adjust the production plan.
That real-time adjustment fundamentally changes the definition of planning. It's no longer planning, it's steering.
It is. And challenge 3 is integrating external factors. The simplified model assumes demand is a static forecast somebody gives you. The enterprise model must integrate external factors like real-time weather data, which can impact logistics or agricultural supply, macroeconomic shifts, influencing raw material prices, sales pricing volatility, and even competitor behavior data into the supply and demand planning engine. These external variables are ingested via the IPAS layer and fed directly into the data science platform for continuous adaptive modeling.
And finally, challenge 4 brings us back to velocity.
Moving from that comfortable quarterly static forecast to daily or even hourly optimization. This is where the sheer volume of data and the speed of required computation render any isolated system obsolete. To optimize hundreds of products across dozens of plants, integrating real-time internal and external factors daily requires a centralized, massively scalable data science platform combined with robust, governed integration and high-quality master data. This entire blueprint is the only way to turn that basic optimization math into a massive, strategic enterprise capability.
We've covered the integration, the quality of the data, and how the intelligence is scaled. Before we look at the final holistic structure, let's quickly review the fundamental concepts of big data via the 3 V's, which really frame the context for the architectural scale we're discussing.
These 3 V's, variety, volume, and velocity, are the enduring benchmark. They're still as relevant as ever. The first V is variety.
Right.
As we detailed in the integration layer section, this necessitates supporting a plethora of data systems, ranging from decades-old legacy databases and flat files to graph databases and streaming IoT feeds.
The second V is volume.
We are firmly in the realm of petabytes and the emerging zettabyte scale in large organizations. The cloud platform infrastructure must be engineered from the ground up, not just to store these huge volumes, but to process them affordably. That means factoring in smart partitioning, archiving, and tiered storage strategies.
And the final V, which is really driving the urgency behind all of this, velocity.
This addresses the demand for real-time response. Whether it's daily production optimization requiring immediate data analysis or consumer clickstream analysis on an e-commerce site demanding instantaneous processing to personalize the next offer, high data velocity must be a foundational design consideration throughout the entire platform.
And to handle that scale and speed, the cloud platform infrastructure has to be comprehensive. It can't be just one or two tools. What are the key components required for a truly holistic cloud analytics and data platform?
It's an end-to-end framework, really. It has to cover the entire life cycle. At the front end, you need data ingestion and data storage capabilities. Then, the governance components, governance and lineage to track data provenance. For processing, we need the cloud data lake infrastructure, data discovery and insights, data modeling, and data process catalog tools. For control, data orchestration is necessary.
And then the consumption part.
Finally, the consumption components, data serving, business intelligence, reporting and dashboarding, and critically, the ability to issue real-time alerts. It's a complete factory for turning raw data into insight and ultimately into action.
Okay, so let's tie all these different threads together now. We've seen the drivers, the pipes, the quality control, and the intelligence engine. Let's look at the ultimate proposed structure, the Data 360 architecture. This is the North Star blueprint made visible.
This architecture illustrates how the entire structure supports the business. At the very top layer, the part users interact with daily, we have the engagement solutions.
So things like customer experience platforms, supply chain operations tools, and enterprise systems like HR and finance.
Correct. Below that top layer is the essential gatekeeper, the identity layer.
And that handles.
That handles identity and access management, consent, and privacy. It establishes clear policies for data usage and accountability for every single interaction, regardless of which engagement solution the customer or employee uses. It ensures every touchpoint is compliant and secure.
Then we hit the core data foundation, where the quality control is. The master data hub and its accompanying master data governance framework.
The hub handles the orchestration, distribution, and integration of that golden record across the enterprise. The governance framework ensures quality through its rigorous life cycle. Data load, standardize to clean the data, match to identify and resolve duplicates, calculate the best record, run, validate, and data quality checks, and finally, activate the certified record back into the systems that need it.
And sitting logically beneath that governance layer is the Data 360 platform itself, which translates all that raw, high-quality data into actual business value. And this platform seems to be organized around three primary activity streams.
That's right. Stream 1 is operational processes. This is data related to the core running of the business, things like licenses, utilization metrics, invoices, and subscriptions. Stream 2 is analytics modeling. This is the innovation engine.
Okay.
This is where you have personalization models, key account profiling, advanced predictive insights, and high-fidelity financial modeling.
And Stream 3 provides the measurement and the feedback loop. Insights.
These are the high-level, blended measurements derived from both operational and experience data. Things like omni-channel measurement, customer health scores, net promoter score, sentiment analysis, and customer churn metrics. These insights aren't static reports. They are the continuously updated metrics that guide strategic decisions.
And powering this entire comprehensive structure, the bedrock below all three of those streams.
That is the cloud technology platform. This is the foundational stack that makes the whole machine run. The integration platform, the master data management and governance systems, the data lake and big data management infrastructure, the data intelligence engine, and the API management hub. It is the comprehensive, holistic platform required to support the entire zettabyte enterprise vision.
That is a fascinating and, I have to say, staggering blueprint. Stepping back, the North Star architecture we've detailed today seems to be fundamentally defined by three elements working in seamless synergy. High-quality centralized data achieved through the master data hub and governance. Intelligent automation powered by the data science platform and cloud extensibility. And finally, the essential glue that integrates this heterogeneous world, the integration platform as a service, or ITaaS.
By focusing on this architectural unity, companies can move entirely from reactive operations, where the majority of IT effort is spent just reconciling disconnected data, to truly predictive operations, where they anticipate market shifts, customer needs, and machine failures proactively.
So the biggest challenge, and therefore the biggest architectural shift, isn't really about adopting a new cloud provider or a new piece of software. It's ensuring that every single data source, no matter how old or obscure, from a legacy database running a critical transaction to a live IoT sensor sending continuous telemetry, is not only connected but also governed and integrated in real time.
And this raises an important final question for you, the listener, to maybe mull over as you think about your own organization.
Yeah.
In your domain, what single source of previously ignored or siloed data Data that is currently disconnected or ungoverned, if it were connected and governed today, would deliver the most exponential business gain tomorrow.
That data might be sitting right there, waiting for the proper integration and governance framework to unlock its true strategic value. Thank you for joining us for this deep dive into the blueprint of the future enterprise.
My pleasure.
We'll talk to you next time.